Hello, I'd like to talk about electrostatic discharge, that's ESD ratings of semiconductor devices, and specifically I'm going to talk about military qualified radiation hardened semiconductor devices. So that's going to be diodes, transistors, hybrid circuits, integrated circuits. At the manufacturing facility where your electronics are going to be assembled, they need to be following electrostatic discharge controls. There are several standards out there to do that, both some commercial standards, space grade standards like NASA. All ESD control programs are going to be based around the human body model discharge rating of these devices. The human body model, or HBM ESD classification, is really important because we need to make sure your manufacturing facility has the proper ESD controls in place so that the electronics don't become damaged, or even worse, latent damage that you don't find out about until your product gets into orbit. A question I get asked a lot is, so I've got a military qualified radiation hardened device. Does that mean it's also hardened for ESD? And the answer is not necessarily. It's something we need to check. How do you check? All of the ratings for these military qualified semiconductor devices are posted on a government website. And on there, they have databases that call out the ESD rating for every single device. And it's also tracked by location. So the ESD rating can actually change depending on who makes it and where they make it. You know, a classic example would be the 2N2222A. There's actually ESD ratings for that ranging from as low as 500 volts to as high as 8,000 volts. Quite a spread, and it really depends mostly on the manufacturer and also the manufacturing location. I recently went through the database online just to look at what the spread is for all the different devices based off the ESD classification. To start with, we've got the discrete semiconductors, so that's diodes and transistors. Those are qualified under MIL PRF 19500. What we can see is that we've got a lot of parts that are actually non-sensitive, and that means they have an ESD, human body model, ESD rating of 16 kV or higher. The number of parts actually goes down as we go to the lower classifications, which is interesting. And the main reason for that is the discrete semiconductor devices are actually bigger, so they can handle more power, they can handle more current. Ultimately, the human body model discharge is a current pulse. So even though it's given as a voltage, it's actually a current pulse. So and also according to this data, there's only just over 100 devices that are not acceptable with standard commercial ESD controls. If we're using the NASA recommended controls, ESD class of 1A or better, then there's only 19 parts that don't meet that. I would point out that the parts with the lower ESD values are usually more popular because they have higher performance. Okay, next we have hybrid circuits. These are qualified under MIL PRF 38534. These hybrid circuits are going to look like integrated circuits, except when you delid them, what you'll see is that what they've done is on top of a ceramic substrate, they've mounted individual dies and bonded them. It's in a very small package, and it's a lot more efficient than taking discrete transistors and diodes and trying to wire them together on a printed wiring board or printed circuit board. In terms of the ESD ratings for these hybrid devices, we can actually see most of them actually have a ESD rating greater than 500 volts. A lot of them have been qualified under a very old human body model rating, which was called Class 1. Class 1 has been superseded, and it's been broken up into Class 0, Class 1A, Class 1B, and Class 1C. Unfortunately, Class 1, all you can say, it's the human body model rating for it is less than 2 kV, which is basically useless. It doesn't tell us anything. The manufacturer is actually supposed to give us the actual level that they tested to without failure, But most of those parts, and there are over 3,000 parts, that the vendor did not report it. One mistake I think people do when they look at that database is they look at, oh, it's class 1, therefore it must be class 1C because it's 1 kV. So 1 must mean 1 kV. It doesn't mean that. It doesn't mean that. All it means is less than 2 kV. That's it. That's all you can say. What we really need is a minimum value. If it's 250 volts or greater, that's useful information. Less than 2 kV doesn't help us at all. We've got integrated circuits. These are standard integrated circuits. A lot of these are actually commercial devices that you can buy. They've just gone through the military qualification program. Most of the devices have an ESD classification of 2 kV. The reason is because starting from the 1980s, when ESD testing was really taking off, until about 10 years ago, the industry standard practice was to try to design your chips to meet a 2 kV ESD rating. That's because the manufacturing facilities had their human body model target for their ESD control programs set at 2 kV. However, about 10 years ago, the industry got together. Because the fabrication processes were just getting smaller and smaller, it was very, very difficult to meet the 2 kV rating. At the same time, a lot of these facilities were getting their ESD controls down so they could accommodate a 500 volt ESD rated device, no problem. So effectively what industry did was they lowered the susceptibility requirement on the integrated circuits down to 500 volts. But now, at the same time, there's an expectation that manufacturing facilities are going to need to be more diligent, and they need to get their ESD controls dialed down so that they can support a 500 volt rated device rather than the old 2 kV. Specifically for the military qualified integrated circuits, we can actually see that down at class 1A, these would not be acceptable for commercial programs, but it would be acceptable for NASA. There's only 342, so not a whole lot. But we still have the problem with the class 1 rating. So these are the old heritage devices. They're rated for less than 2 kV unless the manufacturer specifies it. Some of the parts, especially some of the more popular parts that are used a lot and probably have gotten complaints in the past, the database has been updated with a little clarification on what the actual ESD rating is. But what I have shown here, there are over 4,000 parts that are still listed as class 1 with no clarification. So without any more information, we have to classify it as a class 0 part. So, and that's a problem, again, because NASA recommends a minimum ESD rating of 1A for your ESD controls in your manufacturing facility. If you have a class 1 part, you've got to figure out what your actual human body model rating is, or you need to notify your ESD control folks so that they can put in special processes for that. So if you're working with space electronics, just because your part is radiation tolerant, radiation hardened, it doesn't mean it's non-sensitive to ESD. You need to go through your BOM, identify your human body model ratings for all your parts, and communicate that information to your ESD controls team or the manufacturing facility. My name's Russell Carroll, and thanks for watching.